Hi, I'm Wayne Lack, and this is January 2013, Core 3 AQA. We're doing question 6, and according to my examiner's report, quite a lot of people struggled with this question. It is quite a tricky question. It proved difficult for most students at some point. So even the students that were doing so well through all the paper, knew all of their stuff, at least most of them tripped up somewhere in this question and lost a mark or two. There's quite a few silly errors as well as there normally is in most questions, but a lot of this is quite tricky stuff to get your head around, so let's turn to the whiteboard and just go through question 6. Okay, so question 6, 6a, show that sec squared x over sec x plus 1 times sec x minus 1 can be written as cosec squared x. So, sort of a typical question. It normally comes up somewhere in a Core 3 paper, something like this. You're going to be using your trigonometric identities that you know. As far as I've got at the minute, we've got sec squared x. So we know what sec squared x equals. There's a rule for what that equals. Sec squared x equals tan squared x plus 1. So, I mean, we can see where that gets us. That's a rule that should come to head straight away that involves sec. So on the top of this we can have this tan squared x plus 1. Now the question becomes, what do we do with the bottom one? Because at the minute there doesn't look like much we can do. You'll notice it's a difference of 2 squares, so if we expand out the bottom, I'm going to do it over here, we'll get sec squared x minus 1. It's a difference of 2 squares. And if you didn't notice that, when you expand it you'll get that anyway. But if you did notice, it makes it quicker, and you might realise sec squared x minus 1 is going to equal tan squared x using the same relationship that we've just used. So go ahead and put that as our denominator. So as this helps us, it's got, instead of it all being in terms of sec squared, it's now in terms of tan. Has that helped us if we need to get to cosec? Well, let's see what other rules we know. I'll bring this over here. We can break this up into tan squared x over tan squared x plus 1 over tan squared x. Okay, that's just a rule we did probably back in year 9, that you can break up fractions in this way, because that equals 1 plus, and 1 over tan squared x is cot squared x. And there's another rule, that 1 plus cot squared x equals cosec squared x. Okay, so that can be really difficult to notice. Not many people notice it like that. It's just looking at it and you see sec squared x. What rules do you know? Well, there's that rule. See where it takes you. If it took you absolutely nowhere, go back and see what other rules you know. But it's quite an easy one once you get going. It's just a lot of people don't get over the first hurdle of remembering this formula. So just remember your trigonometric formula and you should actually be okay with that question. So, part B, hence solve sec squared x over sec x plus 1 times sec x minus 1 equals cosec plus 3. Again, there's the word hence, which means using something we've done before, and you can probably see we've done this part before. We know that that equals cosec squared x, so we can exchange that for cosec squared x. And you should know from Core 2 the sorts of questions that you're going to get with this sort of stuff. We know we're going to form some sort of quadratic formula to boil it down to find out what x equals, to find our solutions in between these. It's in degrees, that's why it's in between minus 180 and 180. We're going to find the values of x. So we can take these over this side and get minus cosec x minus 3 equals 0 straight away. Because we know we're going to need to find the x values. So that doesn't factorise, which is never nice. So we can find cosec x rather than just not finding x. We can find cosec x with the quadratic formula rather than factorising it. So I've got minus b, and it's minus 1 at the minute, so it'll be minus 1, which is 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c. C is minus 3, so that becomes plus 12. So altogether it becomes root 13 all over 2a, which is 2 because a is 1. So we've got 1 plus or minus root 13 over 2. So that's going to give us two values for cosec x. So cosec x equals, so firstly, if you plus the root 13 over 2, we get 2.3. You can type that into your calculator. And if you do 1 minus root 13 over 2, you should get minus 1.3. So those are your two values for cosec x. Are we finished yet? Not quite. What is cosec? It's 1 over sine. So we get 1 over sine x, because you can't do cosec to the minus 1 of x. That's not a thing on your calculator. So that equals the 2.3 and the minus 1.3, so it's the same thing. So we can do, so to find our x values, we can do sine to the minus 1 of, firstly, 1 over 2.3, and then we can do sine to the minus 1 of 1 over minus 1.3. So just doing the inverse of these things, and then sine to the minus 1 is the inverse function of them. And you'll find that sine to the minus 1 is going to give you 26 degrees for this one. 26 degrees for the positive one. Make sure your calculator is in degrees mode. And sine to the minus 1 of 1 over minus 1.3 gives you minus 50 degrees. This is all to the nearest degree. So that's unlikely to be all of our answers, because it never is. So think about a sine graph for a second. It goes like this. Between minus 180 and 180, which is not quite what you'd expect. Normally it goes between 0 and 360. This time they're doing it like this. And we can use the symmetry. If there's a value at minus 50, then there'll be a value here in line with it in the y. Now 50 is 40 away from 90, so if you do 40 the other side of 90, we're also going to get minus 130. And then 26 is a value here, so there's going to be a value here in line with it in the y. 26 is 64 away from 90, so if you plus 64, we get 154. And those are the four values of x. So we have now solved it. So I'll go through that again in case I lost you at any point. So firstly, we found a quadratic. It wouldn't factorise, we had to use the quadratic formula to find our values of cosec. We know that cosec is 1 over sine, so we know that 1 over sine x must equal those same two values, 2.3 and minus 1.3. So sine x must equal 1 over 2.3 and 1 over minus 1.3. So x must equal sine to the minus 1 of 1 over 2.3 and sine to the minus 1 of 1 over minus 1.3 to get your values, and then you use the symmetry of the curve to find your other two. And we know that there's not going to be any more than that. So C, hence solve sec squared 2 theta minus 60, and basically the same thing, but all the x's have been replaced with 2 theta minus 60. And this time it's between 0 and 90, and we've got to find the values of theta. So we have just solved this sort of equation, but now x is equaling 2 theta minus 60, rather than just x. So we found these four values before. Those four values will be the same, but now instead of equaling x, they will equal 2 theta minus 60. So we can say that 2 theta minus 60 equals 26 minus 50, nearly put the minus there, 154 and minus 130. So to find theta, you've got to plus on 60 to each of the values and divide them by 2. So that's rearranging it to find theta on its own. So firstly, this one that's plus 60, that gets 86 divided by 2 is 43. And the minus 50, if you add 60, becomes 10 divided by 2 is 5. 154, if you add 60, is 214 divided by 2 is above 90, so we can omit that one. And minus 130 plus 60 is minus 70 divided by 2 is minus 35, which is again out of the range. So we have 43 degrees and 5 degrees as our final answer. Altogether, this was, I believe, 3, 6 and 2. This question, or this sort of question, is extremely common, rearranging that. This is always the way that they start, trying to give you something hideous and use your rules. And they often do something else at the end here, jazzy like this. So this is question 6, I hope this helped. And I'll see you at question 7.